Welcome to class, ladies and gentlemen. It is Wednesday, February 20th. Mr. Eicher here to teach you a much shorter lesson in this video than yesterday. I'd like to review confidence interval formulas, introduce you to a new one, and that'll give us 4 confidence interval formulas that you'll need to know for the AP exam. There's only one left in the course, so we have a total of 5 of them. And then after that, I'd like to show you some calculator shortcuts. And then you'll be doing some Khan Academy work. So let's review the general formula for any confidence interval. Any confidence interval is the statistic plus or minus the margin of error. So remember, your statistic is your midpoint of the interval. The margin of error extends to the left and to the right, plus and minus the margin of error. Plus and minus margin of error. To calculate margin of error, that would be plus or minus the critical value times the standard deviation of the statistic. And the statistic itself is your estimate, your point estimate. So that's the general formula. There's little times here. Sorry, I ran out of space. But see, if you remember the next to the one sample interval for P and the one sample T interval for mu. So pause this video and see if you remember those formulas. So here we have the P hat plus or minus Z star times the square root of P hat times 1 minus P hat over N. Remember Z star, we use inverse norm to find that critical value. Whereas the next formula, the T star, we use inverse T. So with the T intervals go with quantitative data, which use means, and Z, critical values, goes with categorical data, which is using proportions. So I wanted to write those two formulas so you could see the next one and what it looks like. We talked about this last week when I was still with you, not gallivanting on the East Coast. So let's check out the next formula, the 2-sample Z interval for the difference in proportions. So the 2-sample Z interval for the difference in proportions. We'd like to estimate this difference in population proportions. So our point estimate that we use would be P hat 1 minus P hat 2. That's our statistic. It's a difference of 2 statistics. So I usually put these in parentheses just to set it apart from the rest. Plus or minus. Since it's a proportion, we use a Z star. And then our standard deviation of the statistic would be, see if I can fit this on the screen. We have similar looking formula to the one above. We have P hat 1 times 1 minus P hat 1, and we have P hat 2, the second proportion, times 1 minus P hat 2. So that's the interval that we use to estimate a difference in population proportions. The last interval that we'll look at in this chapter is a 2-sample T interval for a difference in means. So we'd like to estimate the difference in population means. The statistic that we would use would be x bar 1 minus x bar 2. The difference in sample means would estimate the difference in population means, and it would be an unbiased estimate if both of those sample means came from random samples. One of our conditions, randomization of some sort. And then plus or minus the T star, again use inverse T for that, T star. And we'd have one big square root again, which is unique here. Looks almost like the last one. But what we have is, again, the first sample size in that denominator, the second sample size in the second denominator. The numerator is the sample variance. The sample variance would be the sample standard deviation from the first squared, that makes it variance, and then the sample standard deviation of the second sample squared. And that would be the sample variance. So we have this formula. It's kind of big formula. Students will sometimes forget to square the numerators there. And for t star, we're going to use inverse t. Inverse t. You need the area, and that's what you would get with like 95% confidence. You'd use an area of 0.975 because you got to add the tail. And you need a degree of freedom. The degree of freedom that you would use, there's two ways. One way that's pretty common is you take the smaller of the two sample sizes minus 1. So if it happens to be n1, then you'd subtract 1, and that would be your degrees of freedom. If it's your n2 is smaller, or the smallest sample size, then you do that minus 1. This is a conservative approach to the degrees of freedom. The second way to calculate degrees of freedom is let the calculator calculate it for us. It's a pretty gnarly formula. Kudos to Timothy Chang for memorizing it last year. I do not have the formula memorized, but he does, ergo he's better at stats. Ask him, hey, Timothy, do you remember the degrees of freedom formula for a two-sample t interval? See if he remembers. And have the answer on Google so you can check that he has the answer right. But this is our new interval. We have conditions like we usually do. We have a random condition that makes sure that this estimate is an unbiased estimate, and we can make inferences to the population. We have a normal condition, which allows us to see our critical value as a correct critical value, and that our sampling distribution is roughly normal. And then we have an independent condition, which justifies the use of this formula. So we have three parts to the formula, 1, 2, 3, and each part has its own condition: the random condition, the normal condition, and the independent condition. So I would encourage you to memorize these formulas. You could see FRQs, or multiple choice questions, that will show you these formulas with numbers plugged in and ask you which is the correct formula with the numbers plugged in. I'd like to briefly show you kind of where this formula comes from to justify a little bit of mathiness, and then we'll get to our last part of the class. So let me erase these and go over to this little, we'll go in a whiteboard setting here. So if you wanted, we kind of did this in yesterday's introduction, but if you wanted the standard deviation of the difference into sample means for the sampling distribution, you would take the standard deviation from the first x bar 1 plus the standard deviation of the second x bar 2, the second one. But remember, with standard deviations of random variables, we can't add them, so we have to change these to variance. So let's square these. This is the Pythagorean theorem of statistics related to that. Now let's substitute. Sigma x bar 1 would be sigma over the square root of n, and that's for the first, and then square that, plus standard deviation of x bar 2 would be the standard deviation from the second divided by the sample size of the second, and that's squared. Okay, we do a little math here, a little simplification. Square the numerator, square the denominator. The square root of n squared is just n1 plus the standard deviation of 2 squared, and that would be at n2. Now all of this equals the variance of the sampling distribution of x bar 1 minus x bar 2, but if you square root both sides, you would get this, which is looking a lot like our formula that we have in that confidence interval. Now in reality, we don't know these population standard deviations. So really this converts to be S1 squared over N1 plus S2 squared over N2. And because of that, because of the added variability from using the sample standard deviation, with our interval we're going to multiply it by t star, which addresses that added variability. So that was a little bit of a math proof per se to show you, and so you can appreciate where that formula comes from. Let's move on to our last part, looking at some calculator shortcuts. So technology shortcuts with intervals. So the benefits of using these, I don't think I'll have to give too many arguments, but the benefits are it is definitely faster than having to calculate it by hand. There are fewer arithmetic mistakes. And really, in a way, you don't need the formula. Those are all great benefits. However, the drawback, if you use it incorrectly on the AP exam, if you use one of these calculators, then you get no partial credit. It's either all right or all wrong. So it's a little bit of a gamble. The other drawbacks kind of related to this one. If you only use these technology shortcuts, then, well, maybe it's kind of like a IDK, the formula. And then you get to the multiple choice section of the exam and you're not familiar with the formulas. So what I would recommend is to practice the formulas, see if you could write them out each time that you do a question, and then just get the number answers with the calculator shortcut. So let's check these out. I have two of them I want to show you, the 2 sample t interval, which is the new one today, and then a 2 prop z interval, prop for proportion, which is one that we did last week. So let's check these out. Scroll down. Okay, so if you take your calculators out, and you're going to go under, you're going to hit the stat button. I'll write it down here. Stat. You'll be very familiar with this is. It only takes a little bit of practice. If you scroll over 2 to the right, under tests, there is the gold mine of a bunch of tests and intervals. So we're looking for first 2 sample t-test. On my calculator, it's number 4. Be careful not to use number 3, which says 2 sample z-test. We don't want that. We want 2 sample t-test. So if, oh, sorry, actually, take that back. Erase. We don't want the test. We want, scroll down, we want a 2 sample t interval, which is number 0 on my calculator, the TI-84 Plus edition. If only I had a CE. Okay, so even though the menu says tests and intervals are all under the same menu. Again, number 0. Don't pick number 9, which says 2 samp z int. So we'll hit select or enter on number 0, and you have this option, data or stats. Well, I've given you here stats. I've not given you the raw data. So if you have the data in lists, list 1 and list 2, then you could run this interval. But if you just have the summary stats, which is very, very common on the AP exam, then you'll pick stats. So you can go left or right and then hit enter until it says stats. In this question, I've just given you some made-up stats here so we could practice this. So for our x bar 1 is the first thing on the calculator. Maybe I'll write that right here. X bar 1. We're going to type this information. 75 is the mean for the first group. So 75, enter. SX1, that's the sample standard deviation. That would be 10, so type that, 10, enter. N1 is the sample size for the first group, 100. And then repeat the same thing with the other x bar 2, sx2, and n2. So that would be x bar 2 is 72, sx2 is 8, and the sample size for the second group is 50. When you hit enter, it asks for the confidence level, and I've indicated right here it's a 95%. So 0.95. You gotta get the point in there, people. Get to the point. And then scroll down. We never pool, so we say no on pooling. What pooling is should we assume that the population variances are the same? If they are, then we will pool the standard deviations. Well, I have no clue, and we never really have a good clue if the population variances are equal. So we always say no. No, don't pool. No going in the pool. Don't do it. No pooling. It sounded like pulling. No pulling teeth or something. I hope this video isn't pulling teeth. Okay, so we hit calculate at the very bottom. Bada bing, bada boom. And the answer we get is, I'll write it over here because I ran out of space. The answer I get is 0.01, 5.99-ish. Those numbers seem kind of small compared to the numbers that I gave you right here. I'll get rid of this stuff. But notice this is a difference. So the difference in sample means, the sample mean difference is 3, which is the midpoint of this interval is 3. It looks like it goes from about 0 to 6, and the midpoint is 3. That's the difference in those sample means. We also get a degrees of freedom. Earlier I had mentioned the calculator will give us a very, very accurate degrees of freedom, which is 119.4, it looks like. Just round it to one decimal place. And then if you hit the down arrow, you can see the inputs, the sample mean, sample standard deviation, and sample size. So this information is what you would record if you were using this calculator shortcut. So when you're doing your homework, I would encourage you to do two things. Number one, try to use the formula, and number two, try to use the calculator and be familiar with both. The last thing I'd like to talk about is how to do a two proportion z-test, or sorry, z-interval on the calculator. I guess I could have just hit the one button that erases it all at once, but I'll do it. Anyway. Okay, so if you go to Stat, go over to Tests, and we scroll down to 2 prop. Anytime you're doing a proportion test, the TI calculator calls it prop. It never calls it samp for sample, which isn't statistically accurate, but the way that they wanted to identify the name is with prop, so it can be helpful. On my calculator, it is number B, 2 prop z interval. If you select that, you have these options: x1, n1, x2, n2. X1 is the number of successes for this given information here for the first group. So we have a p-hat is 47% for men, we'll say. M is for men. So we need how many men responded favorably to the survey. Well, we would take our 90 times 0.47. And you can actually type that right in here. So let's type that 90, hit the times button, and then 0.47, hit enter. And I got 42.3. Here is a big alert. I'm going to like circle the page like crazy, because if you are falling asleep, like, don't miss this part. Oh, it kind of looks like a potato, or maybe a tomato, or a peanut, or a heart. It's very important that this number, when you type it in the calculator, that you round it just to the nearest whole number. the calculator will get confused because it's assuming you're talking about a full number of successes, 42 successes. You can't have 42.3 successes, so we'll put 42 here. So we'll go back, type 42, hit enter. The sample size is 90, so we'll put 90 there, 90, hit enter. X2, let me erase some of this. X2 would be from this sample. We have n times p. That would be 50 times 0.37. And we could type that right in there, 50 times 0.37. And that's 18.5. 18.5 will round up to 19 successes. And we had a sample size of 50. And then lastly, it asks for confidence interval level, confidence level 0.95. Hit calculate. And I got a domain error. If you got, like I did, a domain error, you forgot, like I did because I was talking, you forgot to round one of those decimals. You shouldn't have any decimals in x1, x2, or for that matter, n1 or n2. Okay, so the answer we get, don't have a domain error anymore, the answer we get is, comma, negative 0.08, comma, 0.256. That is our 95% interval. So that is doing that huge formula that we had on the previous page. A couple cautions. We have never pool whenever you're using a two-sample T. And then we never use two-samp Z interval. And we be careful to round in the X for the two-prop Z interval. Two-prop Z int. The reason why we never use two-samp Z interval is because that would be using the population standard deviations, which are often unknown. Thus ends this video. If you'd like to rewatch it, or, like it on YouTube, that'd be cool. But anyway, the rest of class, I would like you to learn a little bit more about this confidence interval for a difference of means. You'll be watching a 3-minute video with Chromebooks if you'd like. That is on the conditions. You'll do some practice problems on the conditions. Then you'll watch constructing a t-interval for means, and that's kind of what I showed you, but I'll watch that video, and then calculating a confidence interval for the difference of means. So that's 10 minutes of videos, and then lastly you have this exercise, 4 questions, and I would recommend doing that exercise both with the formula and with the calculator shortcut that I showed you. Thank you for your attention. I hope these Khan Academy assignments do you well. The bulk of your homework tonight are these assignments. And I believe you might also have a free response question. So with the remainder of class, go and do stats. Thank you very much. See you or talk to you tomorrow.